this is the last video for Math 63, and I'll be going over a sample final exam. And your final will be very much like this. It'll have the same number of questions, the same types of questions, but different questions. So let's go ahead and get started. We start off with 4 of these fraction questions. I have to say, this calculator handles mixed numbers very poorly. It doesn't have an easy way to handle mixed numbers. I'm going to do them without the calculator. Hopefully you have a calculator that works better for fractions. If not, you can turn them into improper fractions rather than mixed numbers if you're using one of these calculators, and then it'll work just fine. But that calculator really only works with improper fractions and not mixed numbers. So anyway, I'll just do it without the calculator. 6 1/4 minus 1 7/12. And so the first thing I'm going to do is make a common denominator here. It's nice, the 12 is going to be our common denominator, and so this will be 6 3/12, 1 7/12. And then because of the subtraction here, I've got to borrow 1 from the 6, and then this will be 12/12 plus the 3/12, which is 15/12. So that'll be 4 8/12, which reduces to 4 2/3. And if you do this as an improper fraction, this will be 12 14/3, and that's also fine. You can answer these as, let's see, did I ask for mixed numbers? Yeah, so I do ask you actually to express your answer as a mixed number in simplest form, which means reduced. Okay? All right. Let's see here. Problem 2. We've got 8 1/2 plus 2 5/6. So again, the first thing I'm going to do here is make a common denominator. I can just turn this into sixths by multiplying by 3/3. So that'll be, let's see, 8 3/6 plus 2 5/6. So that's going to be 10 8/6. So we can both reduce it to 10 4/3, but then also we want to eliminate that improper fraction in the mixed number. There's nothing wrong with improper fractions, but if you're going to use a mixed number, then this fraction should be less than 1. And so our final answer here should be 11 1/3. Okay, problem 3. I've got 1 3/5 divided by 2 1/2. So here, I'm going to turn these into improper fractions. So 5 3 is 8/5 divided by 5/2. And then to divide by a fraction, we're going to multiply by its reciprocal, 2/5. And so this will be 16/25, and there we go. And problem 4, let's see here, 3 3/8 times 6 1/3. So let's see here. So this is 24 3 makes 27/8, and 18 1 is 19/3. Let's see, the 3 goes into 27 9 times, and I think that's it. There's nothing more that we can cancel here. No more common factors, so 9 times 19 is going to be what? I think that's going to be 171/8. Alright, okay. So then if we want to turn this into a mixed number, I'm going to divide 8 into 171, and so that should go 22 5/8 times. Let's see here. Or 22 times with remainder of 5. So 22 times 8 plus 5, 181. Okay. Let's see here, 160, oh, right. So, I should have done this more carefully. One time with 3 left over. There we go, 21 and 3/8. So, yeah, I did it quickly, but then you'll notice that I did check my work because I had done it quickly. And so I found my mistake, did it more carefully, and got the right answer. Okay. Problem 5, write the numbers in order from least to greatest, or smallest to biggest. So, 80.07, 9.18, 983, 8.23, 9.2. Okay. Well, I think I'll line these up along the decimal point. I think that's one of the best ways to go about doing this. You can just kind of look at them as they're sitting there in a row. 8.23, 9.2. Okay, well, the smallest one is clearly this one right here. Right? It has a 0 in the ones place where all of the other numbers are bigger than 1. So that's going to be our first one. And you can add in zeros. Let's see, we've got up to 3 places after the decimal point. So if you want to add in some zeros to be able to compare those, that's fine. Let's see, so that's the smallest one. Now this one has an 8 in the ones place, and the other ones are all bigger than 8. So this will be 8.23. You can put the 0 on the end if you want. Now we have to compare 9.18 and 9.2. That's where the zeros are helpful. You can just compare the tenths place and see that this one is bigger because it has a 2 and this one has a 1. But people sometimes get, fooled thinking that this is 9.2 and this is 9.18, so this one must be bigger. That's not how it works, okay? So, in any event, the next smallest one is going to be the 9.18, and then 9.2 is bigger than that. And then the biggest one, of course, is the one that starts with 80, 80.07. All right. Well, that's problem 5. Problem 6, very similar. I like to put commas in the numbers themselves, so it's 45,108.22, and then this one is 405,105.03, and then 42,110.5, 42,109.9, and then 45,108.7. Okay. Let's see. Yeah, I guess it's helpful to do the same thing, to write these down lined up along the decimal point. These, it's not quite as confusing as that previous problem was, because there's a lot more digits to the left of the decimal point, So we can look at these. You can see these two are the two smallest, right? Because they're both 42,000, whereas these are 45,000. And that's part of the reason why I like to put those commas in there, once I'm doing the problem. They're not in there to begin with, because that makes it a little bit more challenging. But anyway, this one's smaller than this one, right? Because this is 109, this is 100, this is 110. And they're both 42,000. So, smallest one, 42,109.9, and then 42,110.5, and that takes care of those two. Next come these two, which are both 45,108, but this is 0.7 and this is 0.22. And again, it's that same issue that we saw in problem number 5, where it looks like maybe this one's bigger and this one's smaller. If you just compare 7 and 22, it looks like that. But remember, this is not, if you look at the place values, for one thing, the 7 is bigger than the 2. So this is the bigger one. or if you fill in this 0, the 70 is bigger than 22. So this is the next one, 45, 108, 22, and then 45, 108.7. You can put the 0 on the end or not. That's up to you. And then, of course, the biggest one is the 405,105.03. All right, that's problem 6. Problem 7, convert the fractions to decimals and indicate a repeating decimal with a bar over the repeating portion. 7 over 16. So remember that fraction bar means divided by. So we want to do 7 divided by 16, and that is 0.4375. So don't round these off unless the problem asks you to round them off. Problem 8, we've got 11/12. So, same process, 11 divided by 12, 0.916 with the 6 repeating. So the bar just goes over the 6 because the 9 and the 1 don't repeat. Okay, problem 9. 0.04. Now, in starting with problem 9, we want to convert the decimals into fractions. Express your answer in lowest terms. So again, your calculator, most calculators will do this. They have a decimals to fraction function. The graphing calculator also has a decimals to fractions function, and that is in the math key. Let's see here. Which is right here. If you're using one of these calculators, the math key is directly underneath the green alpha key, and when you hit that, choice number 2 is turn it into a decimal. So you would type in 0.04, hit math, choose number 2, and hit enter. Why would I want to turn it into a decimal? Choice number 1 is turn it into a fraction. That's what I want to do. So let's try that again. Choice number 1, turn it into a fraction, and there it is, 1/25. Okay. Now, what's happening here is all about place value. So it's all good and all to know how to do this on the calculator. It's nice also to understand how to do this without a calculator. So, right, this is the ones place, that's the tenths place, that's the hundredths place. So we go to the end of the decimal, the very last place, put the number, even if there's a digit here, we're still going to use that. Here it's just the 4 over 100, and then we reduce that by dividing both of these by 4, and there's our 1/25. Yeah, we'll see that issue with the place value in number 10. I'll talk about that a little bit more here. So again, 0.072 on the calculator. If I type in 0.072, go into math, make it a fraction, 9 over 125. So, doing it without the calculator, well, I would still use a calculator to reduce it, but in any event, again, this is about place value. There's the ones place, there's the tenths place, hundredths place, and the thousandths place. So, this is going to be over 1,000, and we take the whole number, 72. Okay? So, now we can just start dividing it by 2. 36 over 500, 18 over 250, 9 over 125. That actually wasn't so difficult. I thought I was going to resort to using the calculator there, but just dividing by 2 every time works pretty nicely. You could have started out by dividing both of these by 8, but that's a little bit trickier. Okay, let's see here. Problem 11. Express 0.941. We want to convert this to a percent. Okay? So, that means we need to move the decimal point 2 places to the right. This will be 94.1%. Okay? Let's see here. Express 48% as a fraction in lowest terms. Number 12. Okay. So percent means over 100. Percent actually means over 100. I think it's Latin. So this is 48 over 100. And then we just reduce 24 over 50, 12 over 25, and that's as far as we can go. Okay, so 12 over 25 is 48% as a fraction. Number 13, express 3/5 as a percent. Well, I would turn this into a decimal first. Like in the same way, let's see. Oh, well, so we could make this into a decimal first, 0.48, and then that would still be 48 over 100. But over here, I would turn this into a decimal. Do 3 divided by 5, that'll be 0.6. And then it's the same thing as this. Move this decimal point 2 places and fill in that empty space with a 0. And this is 60%. Okay? So it's key to understand this changing from decimals to percents back and forth. Okay? This decimal point slides back and forth 2 places, and that has to do with this issue of 100, right? Because the percent is out of 100. And so it'll always be 100 times bigger than the decimal, and the decimal will always be the percent divided by 100. Okay, let's look at problem 14. Find, now this is where it gets a little confusing, find 0.75% of 180. Okay. So again, there's a couple different ways to approach this. I think the shortest way to go about doing this is to set up this proportion, right? Is over of equals percent over 100. So of is 180. Is what we're looking for. The percent is 0.75. Don't make it into a decimal, right? If you're going to use this method, that percent just goes right into the numerator. See, the 100 is already right here. All right, so now we have to multiply these two and divide by 100. You can think of it as solving an algebra equation or not. You can think of it as multiplying these two and dividing this, dividing by 100. So let's see, 180 times 0.75, and then we have to divide by 100. So 1.35. And there we go. Problem 15. What percent of 75 is 30? Okay, so I'm going to use that same proportion. Is over of equals percent over 100. Is 30. Of is 75. The percent is what we're looking for. Okay, so I'm going to do 30 times 100 divided by 75, and that will be our percentage. 30 times 100, and then divide by 75. X equals 40%. Okay, problem 16. $143 is 65% of what number? Okay. So, of what number? So the of is going to be our x in this case. I'll write this down again since I erased it. Okay, 143 is 65% of what number? So, got everything filled in there. And let's see, I'm going to do 143 times 100. And then divide that by 65. Whoops. 143 times 100 divided by 65. 220. And there we go. Okay. Let's see here. Take a short break. All right, problem 17. Population of Astoria declined from 14,027 in 1920 to 10,349 in 1930. Find the percent decrease during that time and round your answer to the nearest tenth of a percent. Okay, so let's see here. First we need to find the amount of the decrease. 14,027 minus 10,349. So the amount of the decrease there is 3,678. Okay, so remember, to find the percentage of increase or decrease, you take the amount of the increase or decrease divided by the original amount, wherever it started, in this case 14,000, and then that's your is over of. Over here, you'll have percent over 100. Okay? So, the amount of the decrease, 3,678. The original amount, wherever it started, was 14,027. I'll put an X up here. Over 100. So let's see here. What are we going to do? 3678 times 100, and then we're going to divide that by 14,027. And to the nearest tenth of a percent, X is going to be about 26.2%. Okay. Next, we've got another percent word problem. Concert venue has 3 parking lots. Parking lot A holds 64% of the total number of spots. If lot A can hold 1,488 cars, how many parking spots are available in all 3 lots together? So here, there's no obvious is or of situation. And so if that is not as helpful as it is in some situations, you can think of this as the part divided by the whole. Okay? See, neither of these is perfect, right? This is not perfect because you don't always have is and of. This one's not perfect because sometimes the part is larger than the whole, right? If this percentage is over 100, then the part will be larger than the whole. But they are both helpful in solving problems, okay? So, the question here is 1,488 a part or a whole? Well, parking lot A is one of 3 parking lots at this place. It's clearly not all of the parking spaces. That tells me that that 1,488 is a part and not a whole, okay? Let's see here. Then the whole is going to be our X. The percentage we're given in the problem is 64%. And then we put the 100 down there. And now we can go ahead and calculate. Okay. So what do we have to do here? We have to go 1,488 times 100 and then divide that by 64. and that comes out to be 2,325. 2,325. Okay. Problem 19. Julie receives a 12.5% commission on her sales every week. If her sales for the week were $1,680, how much did she earn in commission? Well, so again, this takes a little bit of knowledge about how a sales commission works. Is the commission the part or the whole? Is the amount of the sales a part or a whole? Well, the way sales commissions work, right, is that you get a piece of the sales, a percentage of the sales goes to the salesperson, right? So the commission itself is the part, the weekly sales is the whole, okay? So the $1,680 is going to go down on the bottom. We're going to solve for the commission. This will be 12.5%. And then over 100. Okay, so we're going to go 1680 times 12.5 and then divide by 100. And so X would be an extra $210 for the salesperson, Julie. All right, and that's it for the percentage problems. Next, we just have these two little algebra problems. And the idea here is that we want to get the variable by itself. 3x plus 6 equals 2. So, subtract on both sides by 6. 3x is negative 4. Divide on both sides by 3. X is negative 4/3. If you're using a calculator and you prefer decimals, negative 1.3 repeating. Alright, problem 21, 9x plus 14 equals 5 minus 3x. So here, all we had to do in problem 20 was to get the x by itself. Over here, we've got to collect our x's on one side first, and then isolate the variable from there. So, to do that, I'm going to collect all the x's over on the left-hand side. These cancel out. I'll have 12x plus 14 equals 5. Subtract 14 on both sides. And you have a calculator if you're not comfortable working with negative numbers. 5 minus 14 should give us negative 9. Divide on both sides by 12. So what is that going to be? 3/4, negative 3/4. And again, if you prefer decimals and you do 9 divided by 12, you should get negative 0.75. Okay, let's see here. Next, we get, I believe, a nice proportion problem here about how much earth comes down in a landslide. All right, so 3,000 cubic yards of earth, which was enough to fill 200 dump trucks, right? So 3,000 cubic yards fills 200 dump trucks. A week earlier, we had 42,000 cubic yards come down, and how many dump trucks will we need for that? Okay, so we set up a proportion of, let's say, 3,000 cubic yards, 200 trucks, and now this new slide is 42,000 cubic yards, and notice I match it up with the cubic yards in the other fraction, and then this is what we're solving for. How many trucks will be required? So, let's see, we're going to multiply 200 times 42,000, and then divide by 3,000. Alright, 200 times 42,000, and then divide by 3,000, 2,800. that is quite a lot of truckloads of earth. And it's not so much that we need that many trucks, it's that many loads. Okay? I suppose I misrepresented what the problem was saying there. All right, now we get these C1, V1 equals C2, V2 problems. So, we want to make 75 milliliters of a 2.8 solution from a 5% stock. How much will we need? Okay, so let's see here. Our C1 is 2.8, V1 is 75. Here C2 is 5, and V2 is what we're solving for. So, we're going to multiply these two and divide by the 5. 2.8 times 75, and then divide that by 5. So that says we're going to need 42 milliliters of the 5% stock solution. And then how much water? So 42 milliliters of 5% solution. And then we top it off with water to make up the rest to 75. Looks like it's going to be 33. 33 milliliters of water. And there we go. All right, problem 24 is a similar problem. We want 60 milliliters of 4% solution from a 15% stock solution. All right, so similar scenario, we'll say 4 times 60 equals 15 times V2. So multiply 4 times 60 and then divide by 15. And what's happening here is, this is 240 equals 15 V2. So to get the V2 by itself, we divide by 15. Let's see here. Right. So 240 divided by 15, V2 is going to be 16. Okay, so we need 16 milliliters of that 15% stock solution. And then we need to top it off to make 60 milliliters. So that would be, what, 44 milliliters of water, right? That would make 60. There we go. Okay. Let's see here. All right, so now we haven't really needed it yet, but we're getting into the section where we're going to do these measurement conversions. The last page of the sample final has measurement conversions on it, and the last page of the final that you take when you come to campus next week will also have any conversions that you'll need for the test. If you can't find the conversion that you need while you're taking the test, let me know. I'll either help you to find it on the paper, or I'll supply it to you if I've forgotten. So hopefully I've tried to make sure that all the conversions that we're going to need for the test are going to be on the conversion sheet, but sometimes I do forget. All right, so problem 25, 50 ounces, how many pounds? Okay, well, our conversion sheet says we know that 16 ounces makes 1 pound. So, let's see, I think we should be able to, let's see here. I suppose let's just set up a proportion here. 50 OZ is X pounds. And then over here we know 16 ounces is going to be 1 pound. Okay, so we could do 50, and again, you don't have to make this proportion. If you know whether to multiply or divide over here, just go ahead and do it. This is a good way to double check yourself. So you're going to go 50 times 1 divided by 16, and so that's 3.125. And again, don't round off unless the problem asks you to round it off, 3.125. Problem 26. Let's see here. Here we're going from miles to feet. So 7.5 miles equals how many feet? Okay, well our conversion factor here is that 1 mile is equal to 5,280 feet. In this case we would multiply. But again, if you're not sure, go ahead and set it up. 7.5 miles, x feet. Put the miles on the top, and then put the feet on the bottom. So 7.5 times 5,280, and then divided by 1. 39,600 feet. Okay. Problem 27. Let's see here. 500 milliliters is how many fluid ounces? Okay. Well, let's see. We've got a nice convenient conversion here telling us that 1 milliliter is 0.034 fluid ounces. Okay. That's what we wanted to know. And again, in this case, I would multiply, but let's double check here. 500 milliliters, x fluid ounces. Here, 1 milliliter, 0.034 fluid ounces. Yeah, and there's the multiplication. 500 times that 0.034. And let's see what we get. 17. That's what they call a European pint, right? 500 milliliters. Okay, next one. Problem 28. 165 pounds is how many kilograms? If we know that 1 kilogram is 2.2 pounds, 1 kilogram is 2.2 pounds. Let's see, I would divide here. Let's set it up and take a look. And the other thing you can check, the other way you can check yourself is if you divide and you get fewer kilograms than you have pounds, that's what you should have. Your number of kilograms should always be less than the number of pounds, right? Same thing here, right? The fluid ounces was considerably smaller than the number of milliliters, and that is also the case here. 17 is much smaller than 500. So that's one way you can check yourself. Let's see, I'm going to set up a proportion here, x kilograms, and then over here, oops, we want the pounds on the top. 2.2 pounds, and then 1 kilogram on the bottom. Okay, so 165 times 1, and then divided by 2.2, 75 pounds. Or is that kilograms? Sorry, 75 kilograms. Okay, let's see here. Problem 29. We want to convert 20 meters per second into miles per hour and round it to the nearest hundredth. Okay. Well, again, there's a couple different choices that you have here. You can convert it piece by piece, or you can use the dimensional analysis method. I'll do both, okay? Let's see here. First off, we'll convert meters per second into meters per hour, right? So first, 20 meters per second. If we multiply by 60, then we'll get 1,200. Doing that in my head sloppily. 20 times 60 will be 1,200 meters per minute. And then if we multiply by another 60, I think it's going to be, what, 72,000? Let's see here, 1,200 times 60, yeah, 72,000. 72,000 meters per hour. Okay. Let's see here. So I was doing a lot of that in my head. Really, I mean, what we're doing here is, 20 meters in 1 second, and we want to know how many will there be in 60 seconds, so that's why I multiplied by 60, right? And then the same thing again so that's now 1 minute. And then for 60 minutes, which is 1 hour, that's where we get the 72,000. So 72,000 meters in 1 hour. Next, we can convert the meters into kilometers. Okay? So 72,000 meters is X kilometers if we know that it takes 1,000 meters to make 1 kilometer. 72,000 divided by 1,000 is going to be 72 kilometers per hour. All right, we're getting there. Next, we have to convert that 72 into miles. 72 kilometers converted to miles. So, 72 kilometers is going to be X miles. If we know that 1.61 kilometers is 1 mile. There we go. So let's see here. It's going to be 72 divided by 1.61, or 44.7 miles per hour. And there we go. Okay. So you can see that's kind of a substantial, it's a fair amount of work to convert from meters per second into miles per hour. Okay, and come out with this 44.7. Now, if you want to do this all at once, and again, it's important to understand that this dimensional analysis works differently than the proportions, right? When you set up a proportion, like I did for change meters into, well, let's change the kilometers into miles, right? I matched up across on the other side of the equal sign, matched up the kilometers on top, matched up the miles on the bottom. That's how you set up a proportion. Now, if we're going to do dimensional analysis, we're going to do the opposite of that. 20 meters per second. Now, we're going to put it right next to the same fraction, and we're going to put the 60 seconds in 1 minute and 60 minutes in 1 hour, right? We put them in the opposite positions. So the seconds on the bottom here, on the top here, minutes on the bottom here, on the top here, and that'll put hours in the denominator. That's where we want it. Next, we're going to convert the meters. I'm not sure if we can go straight from meters to miles. You can go from meters to feet and then feet to miles. I'll do the same thing that I did, where we went first to kilometers. So there's 1,000 meters in 1 kilometer. And then we know that 1.61 kilometers makes 1 mile. All right? So the meters on top here, meters on the bottom there. Kilometers on top, kilometers on the bottom. So they go in the opposite order that the proportions do. Okay, but the benefit of this is that it happens all at once. So we go 60 times 60 times 20, 72,000. On the bottom, 1,000 times 1.61, 1610. And then we go 72,000 divided by 1610, 44.7 miles per hour. And hopefully you can see we're making the same calculations, right? This is what we did when we were doing it piece by piece. So whichever one is more helpful to you, then that's the process that you should use. Okay? I'm not saying that this is a simplistic problem. It's a little bit involved. Okay? So that's why I'm saying that whichever method is easier for you to handle this kind of problem, then that's the one that you should really rely on. Okay, let's see here. Problem 30. 19 pesos per liter. This marker is actually running low. Switch back to the purple one. All right. Problem 30. 19 pesos per liter for gas. And we want to turn that into dollars per gallon. Okay. Let's see here. 1 peso. So here's our conversions. 1 peso is 0.0535. So about 5 cents. A little bit more than 5 cents. What else? Liters. We know that 1 gallon equals 3.785 liters. Well, one thing I could do here would be to multiply this 19 times 3.785. What that would tell me is how many pesos it takes to buy a gallon of gasoline. Okay? So that's one way to go about doing this. So 19 times 3.785, 71.915 pesos per gallon. Okay? Because if it's, 19 pesos for 1 liter, for 3.785 liters, you just multiply that 19 by 3.785. Okay, per gallon. So now we got to change the pesos into dollars. So 71.915 pesos is X dollars if we know that it is $0.0535 for 1 peso. And again, the pesos are arranged on the top and the dollars are arranged on the bottom. It doesn't matter whether they go on the top or the bottom. What matters is that they match up. Okay. So what do we have to do here? 71 times that 0.0535. So 71.915 times 0.0535 equals $3 and we'll call it 85 cents. $3.85 per gallon. There we go. All right. Now, if you want to do this by dimensional analysis, let's see, let's make some space here. So, 19 pesos for 1 liter. So, 3.785 liters to make a gallon. Over here, 1 peso is $0.0535. And so really, all we're doing is multiplying those 3 numbers together. And I believe that's what we just did. 3.785 times 19 times 0.0535, $3.85 a gallon. Okay. Now we get to the scientific notation problems. Let's see here. Problem 31. 7,500,000. Okay? So, we're going to take that decimal point, and how far do we have to move it until our number is between 1 and 10? 1, 2, 3, 4, 5, 6, 7 places. So, this is 5.75 times 10 to the 7th power. Alright, same thing with problem 32. It's just we're going in the opposite direction. 0.0064. If we want to make this scientific notation, we go 1, 2, 3 places to get a number between 1 and 10. And so that is 10 to the negative third. 6.4 times 10 to the negative third. Problem 33 and 34 are the opposite. Here we get scientific notation. 1.02 times 10 to the 5th. And so we're going to move that decimal point 5 places to the right to make the number bigger because this is a positive exponent. 1, 2, 3, 4, 5. Fill in those zeros, and so this is 102,000. Let's see, problem 34. I suspect that that will be a negative exponent problem. Yep. So, 8.44 times 10 to the negative 3. So, that decimal place is going to go 3 places to the left to make the number smaller, right? If this is a negative exponent, this number should be getting smaller. 1, 2, 3. Fill in those empty spaces with zeros. 0.00844. There we go. Okay. Now we've got some scientific notation calculations here. Let's see, 7.2 times 10 to the 4th, 8.5 times 10 to the minus 7. And I talked a little bit about using the calculators to do scientific notation. Didn't hear from anybody who was having difficulties, so I'm going to assume that everybody is okay handling whichever calculator they're working with and doing scientific notation there. So my calculator, of course, returns the answer as 0.0612. In scientific notation, that's going to be 6.12 times 10 to the minus 2 power. Let's go, same thing on problem 36, except I believe that's going to be straight division. 3.843 times 10 to the negative 2 over 4.2 times 10 to the negative 8. All right, let's see here. 3.843, 10 to the negative 2, and then we want to divide by 4.2 times 10 to the negative 8, and that comes up on my calculator 915,000. So 1, 2, 3, 4, 5, 9.15 times 10 to the 5th power. And there are ways to set your calculator to return the answer in scientific notation. I just as soon do it myself, unless I'm unless I've got a lot to do, or I'm not sure how to turn these answers into scientific notation. But frequently, I find that it's more work to get the calculator to do something than it is just to do it myself. And so I frequently end up just doing it myself anyway. Okay, let's see, problem 37. 8.35 times 10 to the 4th, 1.2 times 10 to the negative 9th, and then we're dividing by 2 times 10 to the third. Okay. Let's see here. So let's see what we get. 8.35, 10 to the fourth, and then 1.2 times 10 to the negative ninth, and then we'll divide that by 2 times 10 to the third. 5.01 times 10 to the minus 8. And there we go. Alright. Now we just got 2 more problems on the test, and those have to do with the dosage calculation problems. And so you'll have the conversions, you know, for microgram and milligram and all that stuff that we talked about will be on your formula sheet. So let's see here. Problem 38. Patient requires 300 milligrams of aminophylline. It is available as 250 milligrams in 10 milliliters. How many milliliters should be administered? This is a pretty straight ahead proportion, okay? If we know that there's 250 milligrams in every 10 milliliters, then to set up a proportion, we'll line up the milligrams on the top, line up the milliliters on the bottom, and then go ahead and calculate here. So let's see here, 300 times 10, and then we'll divide by 250, and that says we're going to need 12 milliliters. And there we go. Okay. All right, 550 micrograms per kilogram. All right, per kilogram of body weight. So 550 micrograms. And it's important to recognize the difference between the milligrams and the micrograms, okay? There's no complaining about that. If you plan to go into the healthcare industry, that's the kind of thing you need to be good at, okay? Is to notice the difference between those units. That's a big deal. All right, per kilogram of body weight. The patient weighs 160 pounds, and the amoxicillin suspension is 25 milligrams in 10 milliliters. Okay, so this one's a little bit trickier than problem 38. Okay, so let's make some space on the board here. There's a bunch of stuff that we're going to need to do to solve this problem. So first off, patient weighs 160 pounds. We need to know how many kilograms is that. Okay, so we can go ahead and set up a proportion. 160 pounds, X kilograms, and we know that 1 kilogram is 2.2 pounds. Let me double check that, make sure I'm correct. Yeah, okay. So we're just going to do 160 times 1 divided by 2.2. And that'll be 72.73 kilograms. Okay, so I'll hold on to a little bit of accuracy. I'll round it, but I'll round it someplace reasonable so that we don't lose too much accuracy here. All right, so now if we know that we need 550 micrograms for every kilogram of body weight, the patient weighs 72.73 kilograms, how many micrograms are we going to need? This is straight multiplication. This times this divided by 1. Okay, so, and here's the thing. That number, that original number that I rounded off is sitting right here on the calculator. There's no reason to type in a less accurate number. I'm just going to go times 550, and that is 40,000. X equals 40,000 micrograms, okay? Now let's see, if I had typed in 72.73 times 550, I'd be off by a little bit, 40,000.001.5. And that's fine, you know, that's not gonna be a huge difference. And that's why it's important to be smart about rounding this off, okay? Because if you round this in a way that affects the accuracy, it's going to affect how much medicine you end up giving people. Okay, so it's important to pay attention to your accuracy. All right, here's the thing. Notice this is micrograms, this is milligrams. So we need to change that 40,000 micrograms into milligrams. It's going to be 40, right? Because there's 1,000 micrograms in every milligram. So, but let's go ahead and set this up. 40,000 micrograms, X milligrams, and we know that there are 1,000 micrograms in 1 milligram. And so it's 40,000 times 1 divided by 1,000, and so X is 40 milligrams. So that's how much we're supposed to give the patient, 40 milligrams, right? So let's take a breath and look at what we've just done. We turned the 160 pounds into kilograms. And then we use the recommended dosage per kilogram of body weight to figure out how many micrograms we're going to need. And we turn those micrograms into milligrams because that's how the dosage is going to be administered, is in milligrams. Okay, so now we're almost finished here. We got one more proportion to set up. Why don't I just come over and do it right here. 25 milligrams in 10 milliliters. We need 40 milligrams. And the question is, how many milliliters will we need? So, what do we do here? 40 times 10, and then divide that by 25, and the answer is 16 milliliters. Okay. How many milliliters should be administered? 16. So that makes sense. All right. So, that's it for the final exam. Like I said, your test will be very similar to this. You'll have the same number of questions, the same types of questions, but different questions. If you get stuck and you're not sure as you're working through these, let me know. I'll do my best to help you out. Until then, I will see you next week. Thanks.